In this lesson, we're going to take a look at vertex form versus standard form in regards to quadratic functions and parabolas. And all last lesson, we were looking at this equation right down here. Okay. Well, sometimes we're going to be given something in standard form, and there should be a y equals a x squared plus bx plus c, and we're going to want to graph it. Well, we learned last lesson that it was easy to graph using vertex form because we know what the vertex is, and then we can almost use the a to help us find the next point to plot, except of course if it's a fraction like this first problem that I have for us. But we still want to know what it would look like to have this equation in vertex form. So we need to figure out what the go-between is. And that go-between is this formula right here, that the x value of the vertex, technically the h, is equal to negative b over 2a. And this formula may look familiar to you because it's almost half of the quadratic formula, negative b plus or minus the square root part all over 2a. So we're just missing the square root part of the quadratic formula, and that's where this formula came from. So it's nothing actually brand new, it's just half of what you already knew with the quadratic formula. And what it does is if we use the b and the a, plug it in, we'll get the h right here. And that is the x value of the vertex, so if we want the y value, we just plug that back in. So we're going to work through this process and try it with this problem down here. Now the nice thing is that the a, by the way, is the same for both equations. So it's the same for standard form. This a is the same as that a. And hk, of course, is still our vertex like it was in the last lesson. So taking this problem down here, which is try, we're going to first of all steal the a. Okay, so the first thing we're going to do is replace the a with 1/2. So now it's just a matter of finding h and k. So we just have to figure out what our h is, so it's minus something and then plus something on the outside. So the whole goal is to figure out what h and k are. So to do that, I need to use the formula, which is h equals negative b. So in this formula down here, it's negative 10 over, so that's a 10, over 2 times my a, which is 1/2. Okay, and the 1/2 on the bottom times the 2 turns into just a 1. Okay, so this is negative 10 over 1, which is just negative 10. So the x value of my vertex, the h, is negative 10. So it's going to be x minus 10. I could just go ahead and plug that in there for my h value. Okay, well, to get my k, I need to take this, which is my x value. So this is equal to an x, or my h. X, h, they're both an x value of the vertex. Plug it in over here in the original equation and simplify, and that will give me my k, or my y value. Okay, so let's do that work. I've got 1/2 times negative 10 squared plus 10 times negative 10 plus 5. Now if I go ahead and plug this in and work it out, I'll end up with negative 45. Okay, what that means is my k, my y value of the vertex, is negative 45. So I plug that into my equation. So I put negative 45 right here. Okay, so the vertex form for this equation that was in standard form is y equals 1/2 x plus, because we should change the signs here, plus 10 squared minus 45. Okay, so this would be an example of how to convert between standard form and vertex form. Now that process is very helpful when we want to go ahead and graph something, like this particular equation. So we've got negative 3x squared plus 6x minus 1, and what we want to do is, because we like knowing what the vertex is, we want to find the vertex. Okay, and notice that's your first direction, find the vertex, and then indicate if it opens up or down, left, right, and then whether it's wider, narrower, and same slope as x squared. Okay, well, because our a is negative, we learned in the last lesson, this is going to be a sad graph. Okay, now the 3 we also learned is, because it's a whole number, is like slope. So the original slope is 1 In other words, the x squared would have had a 1. This one's a 3, so it's going to be much steeper. So in other words, it's going to be narrower, taller, as the original x squared graph. And again, we're comparing it to this graph that would look like this. This is my x squared. Okay, so we're comparing it to that, and we're going to be drawing the new graph. Now, what we want to do is go ahead and solve for h and k, just like I did on the last one. So we use the formula h equals negative b over 2a, and I plug in what I have, which is negative 6 over 2 times negative 3. Okay, and I work that out, and I'm going to get positive 1. So that means my h is 1. So I can start plugging in my formula. I got f of x is, and again we steal the a, so it's negative 3 parentheses x minus my h value, which is 1, I just found, squared, and then we just have to add k. Well, we got to figure out what k is. So we take our 1 and plug it up in for x in these two places. Okay, so going to rewrite here. We've got negative 3 times 1 squared plus 6 times 1 minus 1. And if I work that out on my calculator, I should get negative 3 plus 6 minus 1, and that's going to give me 2. So that is my k. So I'm over here, my formula, way up over here in the right hand corner, I'm going to say plus 2. Okay, so that's the actual vertex form. So the vertex is 1, 2. So I'm going to go ahead and put a dot at 1, 2 right here. Okay, now my graph, and I'll do it all in yellow, is going to go down from there, and it's going to go down 3 over 1 because I have my a is negative 3. Okay, that's what causes it to go down 3 over 1. So if I click that point, those 2 points on the lab, it would go ahead and graph it for me and give me this. Okay, but the directions say to indicate if it opens up, down, left, right. Well, it opens down. It's narrower than the original red U. You can see the red U there. And you could say that it faces down. It shifted right 1 up to, so you could talk about the fact that it shifts. And then it says label the domain and the range. Okay, so that's the last thing we have to do, is label domain and range. Well, looking at this graph, the domain, if you took a pen, a vertical pen or vertical pencil, and moved it to the left, your graph's going to continue moving further and further to the left, okay, and it's going to continue to move further and further to the right, okay, as it goes down forever. So what that means is my domain is going to go from negative infinity to positive infinity, okay, and you use parentheses because it doesn't touch it. And then the range, if you take a horizontal pencil and just kind of take this line and just move it up, it'll go all the way up to this highest point right here at the vertex. That's as high as you can go, and then we don't have any more points up here. Okay, so that means my range is from negative infinity, because it'll go all the way down forever, all the way up to a height of 2. That's the highest coordinate. That's my maximum. So that's your domain, and that is your range.